Your phone can find your location within a few meters. But here's the crazy part. It doesn't ask Earth where you are. It doesn't scan anything. It just listens. Imagine you're standing somewhere on Earth, and your phone has absolutely no idea where. No compass, no map, nothing. Just a receiver, and silence. So instead, your phone listens to satellites. Not just any satellites, but a constellation of over 30 of them, orbiting about 20,000 kilometers above you, constantly broadcasting one simple thing: the exact time. Each satellite sends a signal carrying the precise moment it was sent. Radio waves travel at the speed of light, about 300,000 kilometers per second. So your phone does simple math. The time the signal took to arrive, multiplied by the speed of light, equals the distance to that satellite. Here's the key idea. If you only know your distance from one satellite, you don't know your location. You know you're somewhere on a giant sphere surrounding that satellite, thousands of kilometers wide. Not helpful yet. Add a second satellite, and you get a second sphere. Where two spheres overlap, you get a circle, much smaller than a sphere, but still not one point. Add a third satellite, and that circle collapses down to just two possible points, one usually way out in space, or deep underground, which your phone instantly discards. So 3 satellites should be enough, right? Here's the part most explanations skip. Your phone's internal clock isn't accurate enough. Satellites use atomic clocks, precise to billionths of a second. Your phone doesn't. Even a tiny clock error throws off every distance calculation. So a 4th satellite isn't for extra positioning. It's used to solve for your phone's clock error at the same time as your position, correcting everything at once. 4 satellites, 1 moment of listening, and your exact location appears. No signal ever sent back to space, just careful listening and simple math. But here's the part almost nobody expects. This entire system only works because of Albert Einstein. GPS satellites move incredibly fast, about 14,000 kilometers per hour. Einstein's special relativity says fast-moving clocks run slower than stationary ones. So relative to you, each satellite's atomic clock ticks slightly behind. But there's a second effect pulling the opposite way. Satellites orbit far from Earth's gravity, and general relativity says clocks in weaker gravity run faster. This effect is actually stronger than the first one. Combined, satellite clocks gain about 38 microseconds every single day compared to clocks on the ground. 38 microseconds sounds tiny. But at the speed of light, that tiny drift adds up to a position error of about 10 kilometers per day if left uncorrected. So engineers pre-adjust every GPS satellite's clock before launch, deliberately ticking slightly slower, so that once relativity speeds it up, it lands exactly on time. Every single time you open Google Maps, your phone solves a math problem involving the speed of light and Einstein's relativity, in under a second. Follow for more, fully